Okay, good evening, students. So, congratulations on getting into the toppers of this wonderful roots contest. Okay, so quickly we can start the session today. So, I am Sadagopan Rajesh and maths educator. And so, yeah, so let us start with some problems, the contest that you have come across, and I am going to pick some problems where most of the students have not answered correctly. Okay, so from that I am going to discuss. So some of you might have answered this correctly, no problem, but you're a part of the group. So just remember that. So let us take this problem, that first problem. I think most of you didn't get this correctly. This is a rabbit problem. Second, try to make it bigger. It's the rabbit problem. So see, the problem is like one move the rabbit in the top left corner of the 3x5 grid can go to any adjacent square along a row, column, or diagonal. One move. The minimum number of moves that can be made the rabbit move to the bottom rightmost corner is 4. So it is in the top left. This rabbit is in top left, and it should go to the bottom right. Okay, so here is one such example. It goes right, diagonal, right, and diagonal. So there are 4 moves. See, 1, 2, 3, and 4. In how many ways the rabbit can make 4 moves to move from the top leftmost corner of the 3x5 to the bottom rightmost corner? So this is one example. You need to include this example and then make the count. So you can actually even try to draw like this, but this is not a healthy approach. This is another way. Okay, so we have got 2 now. So what I'm going to tell you is, I'm going to tell you a theoretical way of doing this problem. Right? Let's see what it is. Sorry, select my pen. Okay. The idea is, since it has to make 4 moves, let me explain that, because this is very simple, 3x5, and I know that some of you are raising hand and then to solve, but I am going to talk only of something called approach to solve the problem. It is more important. Okay, so you can suppose, what if it is going to be something like a 6x10? Will you be drawing? This one is going to have an answer like 8, which is very small, that you can even draw parts and get it. But if it is something like 80, then will you be drawing all the parts? So the approach is very, very important. So I'm going to tell you about that. Okay, so I think some of you are raising the hand, but let me, okay, there is one person called Sudarshan. Let me allow him in, because he wants to tell even before I discuss. But point I wanted to tell is, approach is very important. Approach means even if it is bigger, the approach is going to help you. Okay, this is the smaller one, 3x5. Okay, anyhow. So let me invite Sudarshan to tell his points, and then after my discussion, I'll emphasize my point again. Sudarshan, he raised a hand.
Yes, sir. So actually, I got people who raised their hand, like if they got a correct, like if they got an answer. So I'm not sure. I got 12 for this answer. Over here. So basically, I divided these arrows. So basically, you would need 2 arrows that go right and 2 arrows that will go like diagonally in the bottom. So like you would need 4 arrows. So over here, so it's basically different combinations of these 2 arrows that go right and 2 arrows that go down. So like one, so you could go in any order. So the first arrow could be any of these 2. So I got like 4 factorial by 2 factorial as the answer, because you'd have to divide it by 2 factorial, because the other 2 arrows with that, like they would be same, because if you would want to go right, they would be the same, and if it want to go down also, there would be 2 that are the same. So I got my answer as 4 factorial by 2 factorial, which is 12.
So you got 12. Okay, see, let me explain that, because sometimes, if you're using the factorial or something, I don't know. I mean, this problem, that is the problem. We are going to use something like, I don't know, you have learned something called factorial and the combinations, and why we are not going to use the down column, because if you stay in the same column, this is column 1, column 2, column 3, column 4, column 5. So every time your move should be go to the next column. Next column means you should either move right or diagonal. Okay, fine. So let me explain. I understand that what you have said, but you need to check what exactly is. Oh, see, let me tell you. Let me tell you an idea approach, another approach, where I am going to fill each cell by a weightage. Okay, that's my idea. Fill each cell by a weightage means a number. It's called as a weightage. What is that? A number. What is that number? The number of ways to reach the cell. Okay, in this, I mean, to reach the cell in this process. Okay. Now, if you are going to take, for example, like this one, this is going to be 0. The reason is because finally, if you have to come here down, that means you have to make 4 moves from C1 to C5. Whether you move right, every move it should move by 1 column. So C1 to C5, you have made 4 moves plus 1, which will be 5 moves. We want only 4 moves. Therefore, this is going to be 0, right? And obviously, the top is also going to be 0. Second, this is 0. And this is not going to be 0. This is 0. This won't be putting the same. And what about this is 0? Because when you move to the column 4, from here you cannot come directly here, right? You need to make 2 moves, either down and diagonal or diagonal, and so that's not going to happen. Okay, and this one is also going to be 0 because you cannot come from column 1 to column 2 here. Okay, so what I'm going to do is I'm going to write the numbers, the weightages. How many ways the rabbit can come to that position. So this cell can come only one way, that is right. This cell can come in one way, that is right. Okay. So I think that student made some mistake. The factorial and all those things won't work here. Because this particular kind of a problem I have projected and given to when a PhD student. This is sometimes very simple. Solution is simple. Sometimes this formula it may not work. Okay. To reach this position, the rabbit has how many ways? What is the weightage of this? The one which I have marked. Okay. Let me put it with something else.
Sir,
Yeah, this one. What is this weightage?
Sir, 2.
2. Okay, I tell you, Padurkar is 2. Why 2? Because 1 plus 1, that is 2. What does that mean?
Yes.
What it means? The reason is the rabbit can go right, or then it can come down and then up. Okay, there are 2 ways to reach that. So what does that? That means you need to best thing is you need to add. So this cell can be attained from the immediate left cell by moving right, or the below one diagonal. Diagonal are of 2 kinds. Either you can move downwards or upwards also. Only thing is you should move from 1 column. because you are in the first column, you need to go to the fifth column. So in 4 moves. So every move, you should move one column. It may be right, or it may be diagonally down or diagonally up. So from there also, you can come diagonal and reach this in the fourth. So that means it can be like this. This way also it can come. So that means the diagonal are of 2 kinds. You need to understand. Okay. So, or it can be like this. You don't need to draw. I'll tell you, the drawing is not a good, healthy approach, because this one has got only 8. So you might draw separate, and somehow you might have the intuition that you have not missed anything and you got everything, and you would have got 8. But what if it is something like 60, 80 like that? That is the point. So my approach, what I'm going to tell here to get that 8, the same approach you can project it. Suppose if it is something like a 7 row, 10 columns like that also, it can work. But only thing is the number of moves will be not be 4, it will be given something else. Okay, let's continue with this. So this number is going to be 1. What is the reason? Because you cannot come from up. No downward is there. No downward, because you will be staying in the same column, either right or diagonally down or diagonally up. These are the only things, because that is going to make you move one column. So this is 1. 1 plus 0 is 1. What about this number? 1 plus 1, 2. Not come from up. What about this number? 2 plus 1, 5.
5.
So what about this number? 2 plus 1, 3.
3.
What about this? 5 plus 3?
8.
8. So the answer is 8. So the factorial and all will not work. You may actually try. What you have, you can just write down all the 12 combinations in the factorial, right? Sometimes that is why the formula never works. The formula has got a conditions. That means the formula will work partly. So therefore it is not 12. It's going to be 8. That's why I'm telling, sometimes no, we think that we get a formula and plug it and get results. Somebody works. How the formula comes? Formulation. So the formula has got a conditions there. Okay, yes.
Yes, I think I just got.
Bhairav.
Sir, could you
Bhairav?
do it again? Could you do it again? What you did, like with the numbers?
What again? Let me tell you. Which one again?
Sir,
You
like
want me
the
to repeat?
numbers, like,
What
when
I'm
you
trying to
started
say
to fill
is, see, you need to concentrate, take your note, pen, and then work, right? There's no point in telling again, do again. Which part you missed? Again means it is there on the board. The part is
no,
what I
sir,
wanted
when you
to
started to fill in the numbers, like the 1, 1, 2, 2.
Yeah, understood. Why you missed it is the question I am asking. See,
No, sir, I
I'll
was-
tell you. Yeah, you need to concentrate now, so you cannot pull back for one student. Please try to understand that why this weightage I have put. That is very important. Sometimes no, we are not concentrating on the mathematics is theory, not formulas. Please understand, it is theory. Formula, someone will give you, plug it and you do and say, I'm good mathematician. It's not going to work. Please mark my words. This is not going to work at all. Okay, it will never work. You may score marks because somebody's formula only are putting. So you need to understand the theory. The most important part, what I'm trying to say is, I am going to put a weightage for every cell, right? Please listen to this again carefully. I'm going to put a weightage. What is that weightage? The weightage is, I'm going to put a number here, that this one tells me the rabbit can move to this position only in one way, right? Okay, so let me again rub and show you. But if you are going, if one is going to pull me back, the problem is it is a pulling for the entire class. But you should understand. Okay, this is only one way the rabbit comes here. There is only one way the rabbit comes here. There are two ways. 1 plus 1, 2. How do you get that? After 1, it goes like this. After this one, it goes like this. So 1 plus 1. Understand? Okay, then what about this? This is 1. Why? 1 plus 0. The only way that the rabbit can come here is Why not from here? No down. If down comes, what happens? You will be in the same column. But column 1 to column 5, you should move. 4 moves means column 1 to column 2, column 2 to column 3, column C. You should move column 1 to column 2, column 2 to column 3, column 3 to column 4, column 4 to column 5, right? Which cell is the next question? So 4 moves comes. If you are going to move down, you are in the same column. Then you will be wasting one extra move. That means you will make 5 moves. Suppose assume that you are in the column 3, you come down. So column 1 to column 2, column 2 to column 3, column 3 to column 3, then column 4, column 5 means you will be making 5 moves. So no down move will be a waste. So you need to move either right or slant or this slant. Okay. Now, why this is 1? Because there is only one way you can come. From here you cannot come, because if you come here, column 2, you should have come directly, the rabbit would have come here. It's not possible because it is the 3rd row. Rabbit is in the 1st row. Rabbit can come diagonally down to the 2nd row only. Not? So there is a 0. That means I am putting weightages. What is weightage? The number of ways the rabbit can reach that cell during the travel. Remember, during the travel, because the rabbit is going to move from the top left to the bottom right corner. Okay. So what happens to this number? This is 1 plus 1, 2. Okay, because now down, you are only looking from the columns. And what about this number? It is 5. Okay, so for that, I think let me show you what are the 5. Sometimes no, why I'm telling this, because I need a space. Okay, if I'm going to, yeah, quickly I can try to draw something here. Okay, see, let me show the moves. So the rabbit has to come here, right? So 2 ways it has come, right? Then another 2, 4, another 1, 5. Because the number of ways it can come here is 2 and then a right. Therefore, 2 ways. There are 2 ways to reach the previous cell, that is immediate left, and then 1 right arrow, that is an extension. So the path is only 2 only. Then the number of ways of reaching here is 2 and then a diagonal. So 2 plus 2, 4. The number of ways of reaching here is 1. So 1, 5. So 5 ways it will reach there. And then after a diagonal here, this will be 5. But here there is a number, right? That is 3. So 5 plus 3 will be what? 8. There are 8 ways you can reach. So it means this is what you should think instead of drawing. Okay, we should always understand one thing mathematically. If it is 8, 6, 10 and all, we can draw and find. What if it is going to be 80? Let me come back to that question. You suppose extend this problem that this is not a 3 by 5 grid. This is something like a 7 by 10 grid. And then I give 9 moves. Remember 9 moves. C1 to C10, 7 by 10. So you cannot keep on drawing. The number will be very big. So, but you can do this by this. Even if it is a 7 by 10, you can put zeros and all those stuffs and start filling the numbers and get the. So that's a very nice idea, right? Because you know, if the rabbit has come here, it should come from diagonally like this, or diagonally up or right. So, but that means we have to count the number of paths for the previous cell. Again, we should keep on going backwards, and therefore, we fill every cell by a weightage. That will help you in how many ways it can reach that cell. And finally, through that, it can go to the destination that is going to be 8. So, it's a nice little idea that you need to do is weightage. That is the most important thing. That will help you when if the size is going to be big. Remember, mathematics is more of theory, more of logic than arithmetic. Okay, the idea is you need to have some very nice, theory to start with. So this problem is putting weightages for cells for the numbers is going to help you in solving the problem. So let's move on to the second one. Okay, this is a good problem. We come here. Right. A teacher asked her students to collect as many 4-digit numbers to satisfy the following condition. Each 4-digit number should be of the form. Okay, the place value, the number is given. Place value thousands, number of ones in the number of threes in the number is that's what in the hundreds place, number of twos in the number, and any valid digit. Beautiful problem. After some time, Shreya collected only 2 such digit numbers, 2113. First of all, 2113. Let's check whether 2113 satisfies. 2113. This is the thousands. This is the hundreds, tens, and units. So thousands, number of ones satisfies. There are 2 ones. Number of threes, yes, there is only 1 3. Number of twos, there is only 1 2 satisfies. Any valid digit. So units place, you have a freedom. Other places you don't have the freedom. Okay, you put a 3. So it satisfies. What about 100, 1022? Okay, let's go for 1022. How many ones? 1 1. How many threes? No threes. How many twos? 2 twos. And then any valid digit. So it satisfies. So Shreya collected only 2. But Sweta collected all such numbers. Number of 4-digit numbers collected by Sweta. That means we should not miss out any number.
Sir, 1022 don't have 3.
Yeah. Tell me. Who is speaking? Akshay Paturkar?
Yes, sir. Sir, 1022 has not 3. So how
Yeah.
does it? So how does
Number
it?
of threes in the number is 03, no? It satisfies. It doesn't see, when I say a number of threes, the number, what it means, 03. It's correct. There is no 3. That's a problem. See, number of persons in the room can vary. The room may have some persons, we are going to tell the number. If nobody is there, what will you say? 0. That's all. Theoretically, it is correct. It's the problem. So the thing is that whether it satisfies the number of means need not be the count has to be a natural number. It can be a whole number. Absence of count is the whole number 0, right? Okay, so number of threes in the number, there is no 3 means we are going to put a 0. It satisfies. It's nothing wrong. Now the point is, okay, you see that, let me go after how to do this kind of problems. First of all, how to track it and how to get all the numbers. So even like the rabbit problem. So the most important thing is you need to have a good start. Okay. See, I will tell you that the thousands place, let's concentrate on the thousands place. It cannot start with 0, right? We'll focus on that. It cannot have a 0. Because it's a 4-digit number, it cannot start with a 0. It cannot be, then cannot be 3 or more. What does that mean? 3, 4, 5, 6, 7, 8 or 9. Why? If suppose I put a 3, what it means is number of ones. Please try to understand number of ones in the number. Number of ones in the number will be 3. Then I must put only all ones to satisfy this 3. Then 1 3, that is also gets a tick. Okay, but when you go to the tens, number of twos, that's a problem. There is no 2. And this is okay, any valid digit. So you don't get. Why can't we put something with 4? There should be 4 threes. But there are 4 digits. Remaining, you have only 3 places. Even if you fill all the threes, you can't get 4 threes. That's a problem. 4 ones, I mean, sorry. So I was talking about the ones, right? 4 ones. It's not possible. So 5, 6. First of all, the length is only 4. So we cannot have 5 or more. Therefore, the start digit cannot be 0. cannot be 3 or more, cannot be 3 or more means 3. So what are the digits left out? 1 or 2. So that is the first thing that you may have to do. Therefore, the thousands place must be 1 or 2 only. Okay, fine. So when it is 1, dash, 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 what do you mean by 1, 1? Okay, then what about the 3s and 2? So let us not have any 3, any 2. Any 3, any 2. Let's see. You can't put a 0 here. So why can't we put a 0 there? 1, 0, second, 2, 3, 4, 5, 6. Any valid digit, number of 3s, number of 2s, and then you can have anything other than, okay, 1 or 2 or 3. You can't put it another 1 because there will be 2 1s. So you can have something like 1004 can come, 1005 can come. Like that
But
you
why
can have.
can 1000 not come?
1000 can also, let me check. 1000
Even
is
1000.
1
Because it satisfies the condition.
Yeah, that's
Yeah. 1000, 3, 4,
Yes,
5,
sir, it
6.
does.
Yes.
Yes. Okay,
That
so you have
satisfies.
these kind of numbers, and then you can have 1022. Okay, that is satisfied. And then you have, what is that? I don't think that you can have something like, if you have 1 dash 0. Okay, the problem is you cannot have 2 3s. If I put another 1, then the number of ones will increase, right? Okay, if I put 1 3, then I have to put 1103, and this will be a tick, but this is a problem, right? So if I have to put something like, what is that?
Then it will not satisfy.
Yeah, 2. If you put, then you need 2 3s. It's not possible. So therefore, it is only with the second 0. No, we can get some idea. 1 followed by. Then what will happen? Can I have a 1 1? It's not possible because
No, sir,
1
it's
1
not
means there will be
possible.
2 1. So
Only
1
one
2.
one.
Because then if 1 1 will
1 2
happen, it
3
will not
3.
satisfy the
Yeah, if
thousands.
you put a 2 or more, what happens is that you have the
Number of
what is
twos
that?
will not be satisfied.
Yeah. So therefore, we cannot have it. I mean, that way you have to work,
Yes, sir.
and then
So we have to find out the numbers manually over here.
yeah, obviously, but we are only shortlisting. No, the only possibility is 1 or 2. Then we are going internally, right? Then we need that 2000. So 1000s, we have some cases we can count. Then we had something with the 2000s. Yes, Bhairav is raising the hand. Please, Bhairav, can you tell me?
Actually, I counted without using manual approach, but I got the wrong answer.
What?
I counted using a manual approach, but I got the wrong answer.
You got the wrong answer.
But I counted without using a manual approach.
This one is not, I mean, see, it's like the on-routine problems. Need to understand that this we cannot call it as a trial and error, right? You have only 1 or 2, and in that you may have to, this is the place value idea, right? So you may have to dig deeper and, I mean, within the case, of course, the second digit can be only 0. It can't be 1 or 2 or 1 or more. Okay, so it has to be 0, and you have 100 working, 1022 working. 101 cannot come. 103 cannot come because 3 2s you don't have space. You need to cut short like that. Okay, and then when you start with 2 1s, you need to have 1s. Okay, either the 2 1s can be, the possibilities are 211 dash or 2 dash 11, or it can be 2 dash dash 21 dash 1. If you have 211 dash, then the number of ones is satisfied. Then you should have a 1, 3.
Sir,
You should have a 1,
3
2.
should
So the
be,
1
last
C has
digit
to
should
come
be
here.
3.
So it's the only possibility with 2, 1. If you have 2 dash 1, 1,
It'll be
1
0.
satisfied, 1, 2 satisfied, 1 is there, right? Then what do you have here? No 3. You can't put a
Yes.
3, so 0, 1.
So 0.
It is satisfied. Then if you have a 2, 1 dash 1, the 2 ones you have a tick, and then 1, 3 that you have to put it here, then there is a problem. Because then you have 3 2s. So that's a problem. So this is not going to work. So then finally you may have to count the numbers, right? Yeah, so I think that I am not going to do the counting, right? So then this is how the problem is. That is just like the place value system. You need to see the place value, and then there is a condition given. I mean, within this number, how many ones, how many twos, how many threes, and any valid digit like that. Okay, yes?
But
Yeah.
I managed to do it without manually, but I got the wrong answer.
What do you mean by wrong answer? I don't understand.
As in, I got the wrong answer, but I managed to count it without doing it manually.
Not able to get you. You got the wrong answer, but you didn't do manually, right? So no.
So I think he means he used a different method to do it, but he
It's
didn't.
okay, no problem. Right. Anyhow, finally you have to count and get the result right.
But I
I'm not having this one. Okay, let us move on to the next problem, right? Because we cannot park on one problem. Let me quickly move to the next problem. I don't know. Space to see. Yeah, because we got a lot of problems. No, tomorrow also we can, if you have anything you can post, then we can discuss. See, a triangle ABC is a triangle with side AC 25 and ABC unit, BCA unit, where A and C are positive integers. So always remember, very important tip that I can give you. I'm going to write the tip here. You need to note down the characters if mentioned, right? For example, like odd, even, prime, composite, integers, etc. Right? So in this problem, you have got AC to be positive integers. That means all the length of the sides are positive integers because we already got a 25. That is a C and a A. Right? So now, either AB nor BC is longer than AC. What does that mean? C is not longer. C is less than or equal to 25. Then A. There it will be equal, we don't know, right? Yeah, not longer than 25. Okay, fine. So that means you have to not write this. Just keep that in mind. Okay, C plus Z equals to A plus X. What are Z and X? Z and X are the length of altitudes falling on A, B, and BC. So let me draw roughly a triangle. Okay, the triangle is ABC, right? CABC. For a so I have got height. Height is falling on AB and it is falling on BC. Height may be falling outside also. This is a rough diagram because the height may fall inside or outside. So the height falling on AC Height falling on BC, sorry. BC is X. So this fellow is X. Okay, that is, this is X. And BC, AB, it is falling on AB, no, that is Z. This is Z. And AC is 25. And BC is going to be A. And AB is given to be C. And in your higher classes, you should know that opposite to vertex C will be given small c. Opposite to vertex A will be small a. That's a convention. In small b, it's not mentioned here. Okay, altitudes are falling. Now, the condition is C plus Z equals to A plus X. So C plus Z. This is given.
Sir, X is the length of, sir, X is the length of A from the intersection.
Not from the intersection, it is full because it's already mentioned on length of the. So I am just putting that, I am marking it is like from here till here, right?
Okay, sir. Okay, thank you.
All this is something AD, this is E. So AD is X. CE is Z. Okay. Because this altitude is given. Just I am trying to draw roughly here. I told you it's a rough figure. Okay, fine. Now C plus Z equals to A plus X. Now very important thing is you know that area of triangle is equal to half into base into height. Right? The height on AC is not given. Height on AB and BC are given. Therefore, we can apply the area of triangle in two different ways. Half into A into X is equal to half into C into Z. If you take A as the base, X will be the height. If you take C as the base, Z will be the height. So half into AX is equal to half into CZ. So you can cancel half and half. That's all. So you get AX is equal to CZ or CZ is equal to. So CZ is equal to AX because half CZ is equal to half AX. This is by area property. Let me rub this. So that is given. The top one is given. Let me rub. I have already explained. This is from area relation. Okay. So we got C plus Z equals to A plus X and CZ is equal to A minus A into X. The sums of the side and the altitude on the side are equal for two of the bases, and the products are also equal. Products are equal is always there. The sums are equal is a special for the triangle. Remember that. It is not always, it is given. But this one is always there for any triangle. It is the side into altitude. Half into side into altitude is the area. So half into side into altitude will be side into altitudes will be equal for all the three sides, respective altitudes. So CZ is equal to AX is there always. Okay, as I have told you from the area property. This one is given. Now these two will imply something. What? I have got an identity. I will tell you the identity. The identity is, let me write it here. C minus Z whole squared is equal to C plus Z whole squared minus 4CZ. Correct? So, but C plus Z is same as A plus X. 4CZ is same as 4AX. So, what is this? A minus X the whole square. So, this is going to imply C minus Z whole squared is equal to C minus Z whole squared is equal to A minus X the whole squared. This implies okay, one sec. This implies something. Yeah, what is that?
C
You write it. C minus Z is equal to,
Is
don't
equal
say
to
A
A
minus X.
minus
A
X.
minus X.
No, plus or minus A minus X. See, always remember, if something like P squared equals to Q squared, don't say P equals to Q. That is a possibility. Or P equals to minus Q. Because if I have p squared and minus 3 the whole square are also equal. 3 and minus 3 are not equal. So if p squared equal to q squared, bases are equal or the bases are negative of each other, then only the squares will be equal. It's a very simple thing. We sometimes miss it. We cancel 2 and write p equals to q. If p squared equals to q squared, p equals to plus or minus q. So plus or minus a minus x, right? Okay, let's move on here. So what we
Sir?
get? Okay. Yes.
Sir, but cannot be minus because A and C are positive integers.
A and C are positive integers, but how do you know A is more than X? And another point, let A and X be positive. Why can't we do a positive minus positive? Why can't C minus Z be negative and the both sides can be negative? Please try to understand. I can have positives. Positive minus positive can happen. No, it can give you negative. You understand my point? Okay, we are not telling that we should not involve. We can have start with positives, but we can involve negatives. We can move the lifts up and down positively, but we can reach basement 1, basement 2 and all, right? In a mall. So please try to understand that movements can be positive, but results can be negative. So here, let me explain that you have C minus Z is equal to A minus X, or C minus Z is equal to X minus A. Okay, there are two possibilities. That's all. So this you have to do this quickly. You need to do the algebra. This is something very simple. Okay. So let me do here. We have got C plus Z is equal to A plus X. It is already given. Let me write this, cut, copy, paste here. I'll tell you why I'm doing that. I'm going to get two set of equations because C minus Z is A minus X. C minus Z is equal to A minus X. This is one possibility. The other possibility is C minus Z is equal to X minus Z. This is other possibility. So we have to involve both. Okay, so either this will happen or that will happen. So on the left hand side, you see C plus Z, C minus Z, you add 2C equals to A. So C equals to A, Z equals to X. This is what you get from left hand side. On the right hand side, if you add 2C equals to 2X, so C equals to X. Sorry, second, C equals to X, and so that means this is one possibility and that is other possibilities. These are the possibilities, right? Okay. Fine. So now you can see what is C equals to A. Isosceles triangle. This is isosceles triangle. What is C equals to X and Z equals to A? C equals to X and Z equals to A means height is equal to a side, side equals to height. That is altitude on, what is X actually? Altitude on BC, that is A. That means the triangle is a right triangle. Okay, this is a right triangle. You can have the right triangle. That means you have something like, yeah, so B is a B, C. So remember, AB is C, sorry, AB is C, and BC is A, and this one is 25, right? And of course, that this A, what is that? X is the length falling on BC. So C equals to X, and A equals to Z. So it's right triangle. So either it is an isosceles triangle or a right angle to triangle. Then you may have to go for the isosceles triangle. So for isosceles triangle, you know that both C and A, okay, neither AB nor BC is longer than AC. Okay, that is given. Therefore, it can take values. It cannot take something like 10, 10, 25 is not possible. Okay, it is I am talking about the isosceles. A and C, A, C, and then 25. So this is not possible because sum of two sides must be greater than the third side. So it should start from where? To start from 13, 13, 25. 14, 14, 25. And so on. Okay, and you should know till where it goes. It is not longer than EC. Okay, that is one thing. And then what about the what about the right angle triangle? Right angle triangle, you have only two combinations. 15, 20, 25 form a right triangle. Of course, the CA can be 15, 20 or it can be 20, 15, 25. And another combination is there, that is 7, 24, 25 and 24, 7 and 25. So you need to count how many triangles isosceles are there, how many triangles. So first, therefore, how many important things. First, you need to know that one geometric result, that area property, and this is given. This is area relation. This always exists for every triangle. Combining these two, you get either C equals to A, Z equals to X. C equals to A means isosceles triangle. And C is X and Z is A means height becomes height for, the height side becomes height for another side. Like that, it can happen. That is, mutual things can happen only in a right triangle. In a right triangle, you have two legs. One leg is perpendicular to other, so it is the height. Like AB is the height to BC, BC is the height to AB. So that means it can be isosceles or right angle triangle. We need to find out how many isosceles are there and how many right triangles. So then you have to count the CA pair, then get the result. So this is what is expected in that problem. Okay, so all these problems know that you have to be a little careful. So once you are growing, that what is more important is the theory. The mathematics, you have already studied area of into base into height. Directly, if I am asking and giving base and height and find area, or area and base and finding height, that is not a big charm. That is needed. But when you come to competition, you need to be tested. You will never know which one should be applied, where it should be applied, how it should be applied. That is the trick. So all we need to know is to observe that the given lengths are integers. Otherwise, you will have infinitely many solutions. And then area property, so apply, and then you get a little algebra you are doing here. It's called as an algebraic geometry. And you get there are only two possible geometric triangles can work, that is isosceles or right triangle. And then since positive integers, you may have to go after the combinations, not many. You may have to count them. Okay. Bhairav has raised a hand, but he is not there.
Oh, I was just going to say that it would be a right triangle with the second possibility.
What?
I was just going to say it would be a right triangle with the second possibility.
Right triangle, is it? Yeah.
Yes.
You see, in the right triangle now, you see that C plus Z. What is C plus Z? What is 24 plus height on 24? 24 plus 7. What is 7 plus height on 7? 7 plus 24. You see, in a right triangle, it happens, right? The side plus the altitude falling. So if there are two legs, perpendicular is 24. So 24 sides, 24, both are equal. Okay, and the products will be equal because half into base into height. So half into 7 as base, you get into 24 as height, or half into 24 as base, 7 as height. So it works. So that means the areas are also equal. Okay, so but you don't get isosceles here because that's why I'm telling. When you get P squared equal to Q squared, you should not think P equals to Q. Then that will give you only isosceles. So you need to say C minus Z whole squared equal to A minus X whole squared. Is this part? So either C minus Z is plus of A minus X or minus of A minus X. Okay, so and we need not bother when we involve the C and Z as to be positive, A and X to be positive. So C and Z, C may be smaller than Z, larger than Z, or maybe equal to Z. But the point is, these positives involved may give results negative. That you don't have. The only thing is you have to check the characters are positive. So plus or minus A minus X, it works. You get C equals to A, Z equals to X, isosceles triangle. C equals to X, Z equals to a right angle triangle. Then look for the integers combinations. 25 should be the hypotenuse. So you cannot have the legs to be crossing 25. It has to be within 25. There are only two Pythagorean triplets, 15, 20, 25, 7, 24, 25. You should be thorough with some basic triplets.
But sir, the none of these are isosceles. So.
What none of these are isosceles? Who is that? What is none of these are isosceles? They don't understand.
Sir, among these Pythagoras triplets, none of these are isosceles. So.
Yeah, Pythagoras will not be isosceles. Isosceles are isosceles. We may have right-angled isosceles triangle also, but that is not happening here. If that happens, we may see the overlapping. What I'm trying to say, to satisfy the given conditions, the triangle could be isosceles or right-angled triangle. Okay. In isosceles, what are all the pairs we have? Solutions means what which satisfies the condition. So isosceles set in CA satisfies, right angle set in CS satisfies. So you need to find that. For that, you need area property, solve it, and you get see. Sometimes no, it is not the feeling. Please try to understand. It's not the feeling will always block the brain because the mind only supplies the feeling. You feel like this. Oh, how can this happen? When you don't believe what is actually happening, mathematics. Obviously, you will not do mathematics. You may be to say certain problems. So this problem, it leads to both possibility of right triangle or isosceles triangle. So that's the key catch. That's why I think most of the students didn't do this problem. I know that. Okay, when I said this paper. So you need to understand that just follow the theory. Whatever information is given, follow it. What comes, no, you have to believe. That's mathematics. Because it's the theory. It's given that the side plus its altitude falling, C plus Z equals to A plus X. But product is always going to be equal. That is there by the area property. When you do algebraically, you get that difference is equal to C minus Z equals to either A minus X or X minus A. So always if sum of a side and the altitude, if one pair is happening, then the triangle will be either right triangle or isosceles triangle. We can algebraically prove it. That's the key point. Okay, so we sometimes you can make a little research and construct problems, or yourself can be ready. So if at all in a triangle, a side and its altitude sum, like that two pairs you get, such triangle can happen only in an isosceles or in a right triangle. So that is what I indirectly gave the problem. So now knowing that, after that you should know, since they are integers, even after giving isosceles, if I don't give integers, then some 12.5, 12, 13.5, 13.5, 25, 13.6, 13.5, all those things will satisfy. Infinitely meaning. So I made the condition, they should be integers. So I make to make it finite. That's why I create the problem. But what is important is the most important part that most of I don't know. After coming over here, can be plus or minus is where mostly students will miss. And they will go for isosceles and do the problem. So let's move on to the next problem. I think we are running out of time for this. Okay, fine. This one. This is a configuration, geometric configuration. You have a 2 by 4 dot grid, 2 rows of 4 dots in each row, like this. How many circles of different positions? Sometimes we will say different radii. Radii means the sizes. So I may have the same size but different positions. So you need to understand the keyword. Positions can be drawn. So same position, if you draw a circle, you should not count 2 times. That's why it's given how many circles of different positions can be drawn. That passes through exactly 4 dots among the 8 dots of this grid. Okay. Fine. So what I'm going to tell you, let me put something like a tick.
Okay, can you explain this question again? I mean, like the keyword. Can you just explain the keyword again?
Keyword is position. Different positions means I can draw the circle here. Okay. You need to listen. And then another. See, this position and this position are different, but they may be of same size. Okay.
It's not compulsory for them to be the same size, right? They can be.
Not able to hear clearly. Yeah.
So the size can be different. They can be same, they may not
Size
be
can
same.
be same. Different positions given. Then what is, it's like, so I say, my name is Rajesh. Sir, is your name Rajesh? Sometimes we ask doubts like that. Different, because we are not convinced. That's what I'm telling. The main villain is the mind. Sometimes even after giving, sometimes I might, instead of asking the actual question, no, I myself might be using the word language problem might be there. Even for the giver or could be for the taker. But the problem is, as far as what words been given, different positions means size may be same, size may be different. But you cannot count the same circle again. For that only different positions have been. Otherwise, one may say I can keep on drawing a lot of circles and say there are infinitely many circles. I mean, that kind of problem can happen. So to avoid that, it's given different positions. Okay, fine. So there can be circles of same size at different positions. Same position circles, you cannot count more than once, right? That's the key thing. Okay, let's see. Now you have, let me put a tick, tick, tick. You have a center here, and with that you can draw a circle, right? So this is one, correct? Like that, like this. How many circles we get? Like this, how many circles? 3 circles, like this one. Okay, this is 3. Because you can have the first and second column, second and third column, or third and fourth column. Okay, so let me rub this. Okay, fine. So can I go after this rectangle? Is it possible? Yes, this center. See, if I take the middle, half plus 1, half and 1 makes some distance. All are half and 1. Like, so right triangle with all hypotenuse or equivalent. So you can draw. In fact, that will be the point of intersection of the diagonals. That's the center. You know, rectangle also has a center. Center is, you should understand what is a center. The center is, you can make a note actually, because it's not even given in books clearly. See, what is a center? The center is a point inside. You take any boundary point and reflect. Okay, any boundary point and reflect to get the same another boundary point. That is called as a center. So for every boundary point to reflect, there is a point inside. It goes to another boundary point. So it's for a rectangle there is a center, for a square there is a center, and they are equal distance. No, this important corners, sharp corners, and ellipse has got a center, and then hyperbola. Hyperbola is an open curve. It will be like this. That also has a center. The reason is, if you reflect, okay, it goes and falls on another. Okay, so that means you should know what is the center. So I can have a rectangle like this. So how many I get? Like this, I get 2, because the first and third column, and then second and, so I get 2 rectangles. Okay. Second. Okay, then do you have, yes, first and fourth column. That also I have 1. You totally have 6.
So there's also the possibility of where the first one in the bottom row, the last one in the bottom row, and the middle 2 in the
yes, this one you can have.
and then we have it also upside down.
Yeah, the center will be outside. I will tell you what, if I go halfway here, somewhere in the middle, if I have the third row, then half and 1.5. This is half and 1.5, right? Plus legs. This one is half and 1.5. This one is half and 1.5. The same way, another reason is, instead of this, okay, the corner 2 in the bottom and the middle 2 top. So you have the middle 2 in the bottom, the corner 2 in the top. You have a circle. So you get 2 more. So 3 plus 2 plus 1 plus 2, 5, 6, 8. Therefore, you get 8 possible circles. So if I have given 3 by 4, then you have to be very careful. So that means this itself is a very good thing to do a research, because I have given this kind of problems even to MTech students. Okay, there are a lot of problems. I am changing the
Yes, sir.
configuration.
You could use the method of the cyclic quadrilaterals, like the opposite angles are 90-90 or supplementary, so it will form
But
a
how do you
slope.
know? How do you know that opposite
Sir.
angles are supplementary? That's okay. But if I'm going to give something like what 4 by 5, just imagine. Okay, this is 2 by 4. What if it is going to be 4 by 5? What if it is going to be 6 by 8? So what I'm trying to say is like, yeah, you need to project. For example, I told you the rabbit problem, first one, that weightages. But even if the size is big, you have to put weightages and quickly get it. You cannot keep on drawing that. And first you have to make a theory that down arrow is not going to happen because of the 4 moves, the conditions given. So some things you have to get rid. Okay, then we can move only row wise or diagonally. The next column. Diagonal can be down or up. So the theory, after getting all these things, we will concentrate on putting weightages. Some theory we need to have. Right? Okay. If you can do with cyclic quadrilateral, no problem. You have to stick to that. But can we stick for if the size is becoming bigger? So what I'm trying to say, we can look for the centers. For example, this can be the center for the 4 points, and it has to pass through exactly 4 points. There's 4 dots. This can be the center for not only this 4, but the outer 4. So this kind of common, this center, we can have 2 circles. Either we can have this circle or we can have this circle. Not drawing like a circle, you have to bear with me, right? You need to understand the idea what I'm talking. Same center is used, 2 different circles. And then this center, we have only 1 circle. And then you can have a center outside. It's what I told, like this one. So you can stick for the centers, you can count for the centers and the different size circles. That's one way. But cyclic quadrilateral, another important point is, it's a converse of this one. In a cyclic quadrilateral, sum of the opposite angles is 180 degree. But if the sum of the opposite angles of a quadrilateral is 180, then a circle can pass through. So it's a converse of property. That way also you can do, but I don't know how you will apply it. So anyhow, this is you get
That's
A during
that's
the test and
tangential
all.
quadrilateral, right? That's tangential quadrilateral, right?
Cyclic quadrilateral.
No, sir, like the one in which the circle passes, circle is inside the quadrilateral.
No, I am talking about passing the inscribed quadrilateral is okay, but we are talking about the quadrilateral passing through the a circle passing through the 4 dots. Okay, that quadrilateral is a cyclic quadrilateral. Anyhow, so what I wanted to tell you is, like, what if this is going to be projected, this problem? How are we going to approach? Can we get that one also? If the size is increased. This is the question that you need to ask yourself to be ready, right? Okay, let's move on to next problem. This one. Okay. Fine. So this is a counting problem. This is called as a combinatorics problem. Okay. A finite sequence is all the 10-digit numbers with different digits written in ascending order as follows. So 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. 1, 0, 2, 3, 4, 5, 6, 7, 9, 8. It's just swapping. 1, 0, 2, 3, 4, 5, 6, 8, 7, 9. And then 1, 0, of course, it goes on. And 9, 8, 7, 6, 5, 4, 3, 2, not 1. 9, 8, 6, 5, 4, 3, 2, 1, 0. It's a very simple 32,68,920 terms in it. It's a finite sequence. And compared to infinite, this is very small. 32,68,920. And it's 100th term only you're asking. Okay, so what it will be the 100th term? So only thing is I should have given the blank to be a little longer, because here, of course, you are not going to fill here. Okay, so first thing is, we know that it is written in ascending order. the different digits. It's actually strictly ascending order should have been given because you are not going to repeat. Okay, and that we know because it is a total of these terms. It's not going to repeat. Okay, so how to close this problem? So first thing is, we know if you have 4 terms, okay, that you should know. If you have 2 terms, AB, then BA, you can write it in 2 different ways. If I have 3, ABC, ACB, BAC, BCA, CAB, then CBA. So you have got 6. This is 2. If you have 4, ABCD, then whatever is the starting, you have 6. So each of them will start, so you'll be having 24. In fact, we can say like the factorial. Factorial is the product of the first so many natural numbers. So 2 terms you can permute in 2 into 1 ways. 3 terms you can permute 3 into 2 into 1, 6 ways. 4 terms, 24 ways, right? Okay, why this is important? Because of course you have a 10 digits. All the 10 digits you cannot permute because 0 cannot be the starter, the 10-digit number, right? Same 10 digits will be permitted. What we want is the 100th term. Before what we do, the first term is 1, 0, 2, 3, 4, 5. Second. One, 0, 2, 3, 4, 5. Then last terms will be 6, 7, 8, 9. So if I'm going to change this 6, 7, 9, 8 and keep on changing finally till 1, 0, 2, 3, 4, 5, we'll get 9, 8, 7, 6. I'm not going to change the first 6. So there will be 24 numbers with 1, 0, 2, 3, 4, 5 starting. Okay, so what I'm going to do, let me put a small list with the start 1, 0, 2, 3, 4, 5. So we have 24 numbers. And then 1, 0, 2, 3, 4, 6. We have another 24 numbers. Okay, fine. 1, 0, 2, 3, 4, 7. We have another 24. 1, 0, 2, 3, 4, 8. That means the last 4 digits in this case are 6, 7, 8, 9 in permutation. That will give you 24 numbers. And next will be 1, 0, 2, 3, 4, 6. The reason is you are writing in ascending order. And then after 1, 0, 2, 3, 4, 5, since you are starting with 5, all numbers are exhausted. So the next it will be starting with 6. So 5 will go. So the last 4 digits will be 5, 7, 8. So remember that your smallest number can happen only if you have smaller digits to the left, the higher digits to the right. Okay. So that is how after 7, it's 24 numbers, then 1, 0, 2, 3, 4, 8, 24 numbers. So totally, though, so far, 96 numbers over. Then we have 4 more numbers. So what are the 4 more numbers? We try to get the 4 numbers. One, 0, 2, 3, 4, 9. 97th number is 5, 6, 7, 8. This is your 97th term. Okay. What is the 98th term? 1 0 2 3 4 9 5 6 8 7. This is your 98th term. 1 0 2 3 4 9 5 7 8 9. Because 6 is over, so you need to go for that. This is your 99th term. I think
So you
made a
repeated
mistake. I
9.
put 9 again.
The 9 is
Yeah.
repeated.
Yes,
Yeah. I understood.
Yes.
Put 9, I should have put 6. Correct?
Sir, if you put 6 in place of 8, so it will become shorter.
I put 7 6 8. That's what I made a mistake. The mistake is two things.
7 6 8.
7 6 8 is the 99th term. And then the 100th term will be, that is what we want. 1 0 2 3 4 9 5 7 8 6. That is your 100th term. Okay. So that means you need to first, why we should go after the last 4 digits? Because that gives you 24. Why not last 5 digits? Last 5 digits will be 120, will be crossing 100. We want the 100th term. So therefore, last 5 digits you can permute in 120 ways. So if the question is about 125th term, then what we could have done, we could have got for the last 5 digits permutation. But since it is less than, it's between 24 and 120. We'll go from 24, 24 like that. It's the only way. Okay, 24, starting with 1 0 2 3 4 5. Another starting with 1 0 2 3 4 6. Another 24. 4 7 24. 4 8 24. Then 4 9. We have to put breaks because we have come closer. We can't straight away get another 24. Then actually we would have done permitted all the last 5 digits. So 96 we have done. The next 4 numbers, 97th, 90. We can slowly move on. Just like a traffic. We are going on a highway, no? Some speed. Then once we enter the city or town, because we can't enter with the same speed. Obviously not possible. So we need to slow down. 97th term, 98, 99, 100. If the problem is after something like 125th term, okay, then we should rush for the what? 5 terms. First 5 terms permutation is 120. Then another 5 terms, slowly we can move 121st, 126. If it is something like 750th term, 6 terms, if you permute, it's 720. So straight away we can go for the last 6 terms permutation and go for the first 4. The first 4, it will be 1 0 2 3 followed by 720 terms, and then 1 0 2 4. You should go for the 30th term. Okay, that is after 720, I mean 750th term. So you need to plan according to what has been expected. And you should know the little permutation about this. Is a counting problem. This is called as a combinatorics in our Olympiad term. There are 4 important things: number theory, algebra, geometry, and combinatorics. So even in geometry, I told you, like if the sum of the bases and altitudes are equal for 2 such triangles, I mean, if in a triangle for 2 such, pairs, then it should be either a right triangle or isosceles. So that is the very interesting something we call the like a lemma, small properties, very interesting properties. So you need to be prepared. And sometimes that rapid problem is something different, a different counting, where instead of the formula and all, that's why I asked it as the first problem. The formula is not going to work there. Okay. And then the diagonal has of 2 categories. It is, you would have put diagonal only, slant, right and slant, 2 right and 2 slant, somebody told. But slant itself are of 2 kinds. And you can't do the, what do you call? I mean, there will be 2 different slants. No, you need to take that into account and then do. So this is why sometimes blindly applying the formula and all, it won't work. So that's why you need to plan some theory. And of course, the problem that the place value also, we need a theory. I mean, you have to be strong with the theory. Okay, anyhow, we are going to discuss more problems tomorrow. I mean, I have selected the problems from, selected the problems from the contest only. And there are a few more problems I have taken for discussion, but I don't know. First, I need to complete the contest problems. Okay, so thank you. I think the time is up.
Thank you.
Okay, thanks very much and for discussion and all. Thank you very much. And I hope that the host, I think, will relieve me. Oh,
Yes, sir. Yeah, thank you so much, sir, for wonderful.
thank you. Thank you very much.
Thank you,
See you
sir.
tomorrow.
Thank you very much.
Bye, sir.
Bye.
Thank you, sir.